Okay, so there's a question in the homework that says, how tall does a mirror have to be for you to be able to see your feet? So this is you. This is your hoodie. Okay. Hands in your pocket. Generally suspicious look. Okay. This is a spitting image. Wait, ears, hair. Okay. And then if we have you standing over here, hi. Let's imagine, okay, so the question is, how tall does, and this is number 2 or 3 on the practice for level 4, how tall does a mirror have to be? Like, how big does it have to be in order for you to see your feet? Okay? You feel like the answer would be like the full height of you, right? But imagine you have a light on your feet. If you wanted to get that light on your feet to your eyes, you have to use the law of reflection. So, boop. And then the angle it hits at is equal to the, oh, I drew this picture terribly. The angle that it hits at has to equal the angle to your eyes, okay? So where does that have to hit? It's at about half your height in order for this angle to equal this angle. Makes sense, right? Yeah. So anytime you buy a mirror that is bigger than half your height, you are wasting your money. It's just there to look pretty.
What if you have to see something above your feet?
Above your feet? You can see something above your feet easily. Like if we put a, it's still, whoa, I didn't draw that well. You'd still easily be able to see that at your eyes. It's what's...
No, I mean if you buy a mirror that's over half your height, you could just use it to look at your upper body.
You can still see your upper body in this. Watch. Here's your waist. Let's say you had a shiny belt buckle. You wanted to get your eyes. Boop. Boop. Still gets to your eyes. And in that situation, the angle here equals the angle here. So anything below your waist is a wasted mirror. I had it pointed out to me that I drew that last picture very poorly. So if your eyes wanted to see your knees, here we go, boop, and that angle would have to equal this angle. It's just really hard to draw on an iPad. Okay, so you'd still be able to see your knees. Okay, good. Okay, we just had a really fun argument. I don't know if this makes any sense to YouTube. Sorry. Okay, let's do more homework. So there's our focal point. Focal point is always half of your, what's called a radius of curvature. Or your, center of curvature. Ooh, I'm really tight. Center of curvature, radius of curvature. And they're having a little, let's have a little object stand here. So let's have a little robot. Okay. It's like a dude in the problem, but let's have a robot. Robots are more interesting. Okay, and we want to figure out what we would do. So first we're going to need rulers. Okay, so for these, the main thing we're going to remember is flat to focal, focal to flat. Flat to focal, focal to flat. So we have our robot. So what we're going to do is we're going to show as though what the laser would do if it was shot off the top of his head, okay? So we're going to take it, and we're going to lay our ruler down, and we're going to go straight flat to the mirror. So, boom. That is not flat. I am sorry, YouTube. We can be very angry with me. It's a lot of negative comments. Okay, so then where it hits the mirror and the focal point, we're going to focus on that. So we go flat, and now we're going to go to focal. So if you've shown a laser light straight from the robot's head and it hit the mirror, it would bounce off and go through the focal point, like that. So flat to focal, focal to flat. Or, I'm sorry, that was flat to focal. Now we're going to do focal to flat. Okay, now our angry little robot is going to focus on the focal point. So if we're going from the head to the focal point, you're going to line your ruler up between those two places. And we're going to draw a line from the head to the focal point and hit the mirror. Okay. And if we have light coming from the focal point, how does it come off? It comes off as flat. And then once we hit the mirror, we're going to go so from focal, and when it comes off, it goes flat, okay? And you look for where, when these two lasers came off, where did it seem like they came back together? Well, they came back together here. So in other words, to an observer, it almost looks like there would be a little laser shining out this light at this position. So you could say, okay, that would be then the top of my robot. So my robot would be here. And upside down, because that's his head. So we can now just answer some basic questions. Is he real or virtual? He is real. Because he's in front of the mirror.
Yeah.
Is he upright or inverted?
Inverted.
Inverted. Ooh, there's a mistake in the solutions. These are not my solutions. I don't know where I got these. That is supposed to say inverted. That is definitely a mistake. And is he bigger or smaller?
Smaller.
Is smaller. One down. Okay, we are going to skip ahead to number 5, which is a concave mirror. And we're going to have a focal point here, curvature here, and we're going to put a robot inside the focal point. Okay. All right, so now we're inside the focal point. People find this to be the hardest one, but it's really not that bad. What you're going to do is you do the same rules, flat to focal, focal to flat. So you start out and you're going to take your laser and you're going to shoot it straight at the mirror. Okay. Now, things that hit the mirror going flat, what do? They go through the focal point. So what you're going to do is you're going to line up between where it hits the mirror and the focal point. And you're going to draw that line, and you're going to make a solid line coming out. But don't move your ruler once you do that.
Except I didn't hit the thing.
So I'll show you why later, but it looks as though this laser actually came from inside of the mirror. So we're going to go back, okay, like that. Oops. All right. We're going to use those in this situation. We didn't have to use them in the last one, though they totally existed in the last one. All right, now, what you're going to do is you're going to line up we're going to do focal to flat. So you're going to line up the focal point and the top of the head with your ruler. And we're going to shine a light off the top of the robot's head as though it came from the focal point. So you line up your ruler with those two, and you're going to go up like that. So that would be our focal. And then once where it hits the mirror, you're then going to do your flat. So you're going to lay it down flat. Okay, so you're going to lay your ruler down flat at that point, and you're going to go out with a solid line, because that's what the light would actually do. And then you're going to continue back into the mirror with those, that's where it looks like the light would have come from. So if you look on the outside, on the real side, you'll see that the two rays of light do not meet. One goes here, one goes here. They don't meet, so you will have no real image. But inside, it looks as though the light is coming from one particular point. So it looks as though our robot's head is here. So now we can answer some questions about the robot. Is the robot real or virtual? Virtual, because he's behind the mirror. Is he upright or inverted?
Upright.
Upright. Is he bigger or smaller?
Bigger.
Yeah, he's bigger. Done. Okay, this is a diverging mirror now. Diverging mirrors, and we covered this in class, look like they have their focal point in here, inside the mirror. So let's have our robot stand somewhere in front of this mirror, which would be bubbling out toward him. And we're going to have our same laser light, and we're going to follow our same rules. So first we're going to do flat. So you're going to lay it down, and you're going to go straight toward the mirror. Flat. And then once you're going to line it up with that focal point. Now, keep in mind, the ones on the left side of the mirror, on the outside of the mirror, they're always going to be solid, because that's what the light actually did. The ones inside the mirror, you're going to draw with a dotted line. I didn't draw that and line that up very well. It's hard to do on an iPad. Okay? So that was our flat to focal. And now, we're going to do our focal to flat. So we're going to line up between our little top of our object and our focal point. So we're going to line them up. And we're going to go, okay, hold on. So you're going to go focal. You're going to try and draw a line to the focal point. Where it hits the mirror, you're going to stop and you're going to lay it flat. Again, solid line where the light actually would go on the left side, and then a dotted line inside the mirror to show it's not really where the light is, but it looks like it's coming from there. Okay, and I didn't draw that well. So, our robot is he real or virtual?
Virtual.
He's virtual, good, nice. He is upright, and he is smaller. Yahtzee.